You might be wondering why we have significant figures at all. Let's say that my house and the school are separated by, well, what I tell you is that they're separated by 5 kilometers. Now, when I say that they're separated by 5 kilometers, that's very different from saying that they are 5.000 kilometers apart. When I say they're separated by 5, all I'm saying is that this digit is a 5, but I don't really know what these digits are. Maybe they're zeros, or maybe they're 5.001 kilometers, or 5.324. I simply have not measured that precisely when what I tell you is that my house is 5 kilometers away. I don't know those extra decimal places. And so there's a difference. And it's important for us to be able to communicate the difference between 5 and 5.000. Sig Figs allow us to make that distinction. So why do we have this rule about leading zeros? Well, pretend for a second that I told you my house is 5 kilometers away. Right? So my house is 5 kilometers away. If you convert this into meters, it's 5,000 meters. But converting to meters just added some zeros. What kinds of zeros are these? These are leading zeros. And so we have to make sure we do not count those leading zeros as significant. Why are these leading zeros not significant? Because I didn't know, when I said 5, I didn't know if it was 5.01 or 5.02, or I just did not know at all what these digits were. So it has to remain the case that these digits are not significant. And so we have to have a rule that says the leading zeros are not significant. Let's see that in practice. If you have the value 6.0 kilometers, and you want to convert that to meters, whoops, this should say meters, you have to multiply by a conversion factor which adds the kilo. But if I have 6.0, see this? This is 6.0. 6.0 is very different from 6,000 because this has 2 sig figs and this has only 1 sig fig. So I have to fix the number of sig figs my answer has. You might think that we should just add a decimal point to the end, but that's not right because now this has 4 sig figs, whereas the original number had only 2 sig figs. What do? The solution is to use scientific notation. By using scientific notation, and this is also incorrect, let's fix this, we can say that the answer is 6.0 times 10 to the 3 meters. And now my final answer has the same number of sig figs as the initial value. So in the practice, you will be converting values and expressing the final answer with the same number of significant figures as the original value.